Welcome back for another deep dive from Peaceful Rooster Experience. You sent this blog post over about stream processing with Apache Spark,
Yeah.
and it really got me thinking. It's kind of like
Yeah,
it's the engine behind how we analyze data in real time.
absolutely.
Like when you think about Twitter trends or fraud detection, even
Mhm.
self-driving cars, they all rely on this stuff.
What's fascinating about stream processing is it's not just about like speed, it's about being able to make decisions and gain insights from data the very moment it becomes available.
Right.
And that's incredibly powerful.
And the blog post uses this analogy of a pipeline,
Right.
which I think is really helpful. So you have these sources where the data is coming from. And that could be things like Kafka files, even just a live connection over a network socket.
Yeah.
And then at the other end, you've got these sinks.
Mm-hmm.
And that's where the processed data ends up.
Yeah.
Maybe it's stored in a database, sent to another application, or visualized on a dashboard. So many options.
It's almost like a water system, right?
Oh, interesting.
Your sources are like springs and reservoirs constantly feeding into the system.
Oh, okay.
And then your sinks are kind of like your faucets and irrigation systems directing the water to where it's needed.
I like that.
And Spark is that infrastructure that connects everything and makes sure the data is flowing smoothly and reliably.
Yeah, that makes sense. And one of the things I found really interesting was this concept of immutable streams.
Right?
So the blog post emphasizes how Spark treats data this way.
Uh-huh.
It's like having this conveyor belt of data coming in.
Yeah.
And you can't just reach out and change something on the belt itself.
Right.
Like if you want to modify the data, you got to create a whole new conveyor belt with those changes.
Yeah, immutability is really a crucial concept in stream processing. And it has some really big advantages when you're dealing with these potentially massive
Sure.
amounts of data. It's kind of like having version control for your data. Each transformation creates a new version, making it incredibly easy to track changes, reproduce results, and if something goes wrong, even recover from errors.
That makes a lot of sense. And we even had some code examples in the blog post that really helped me visualize it.
Yeah.
Like, converting all incoming messages to uppercase or filtering out messages that are below a certain length.
Right.
And each of those actions, it's creating a brand new stream, right? Leaving the original data untouched.
Exactly. And that's key for maintaining data integrity and just making the entire system more robust. And building on that idea of immutable streams, Spark gives you this really powerful set of tools, these transformations and aggregations.
Okay, so break those down for me a little bit. What's the difference between a transformation and an aggregation?
So think of transformations as individual tweaks that you're making to the data, right?
Okay.
Like you're manipulating individual data points without changing the overall structure of the stream. Filtering would be a great example of a transformation.
Okay, so like the blog post used the example of filtering out error logs.
Right.
So if you only want to see log entries that contain the word error, you could use a transformation to just filter out everything else.
Exactly. And aggregations, on the other hand, those are more about summarizing the data to gain some broader insights, right? Combining multiple data points to extract some meaningful information.
Okay, so like calculating the total number of website visits you're getting each minute?
Yeah.
Or figuring out which product pages are most popular?
Precisely. And when you start combining transformations and aggregations, that's when you really start to unlock the true power of this real-time analytics. You can filter for specific events, count occurrences, calculate averages, all sorts of things to understand what's happening in your data as it unfolds.
Right. Yeah, I can already see how that would be super useful for things like monitoring website traffic in real time.
Absolutely.
But then the blog post takes it even further with this concept of windowed aggregations.
Right.
And I'm curious, what's that all about?
So windowed aggregations are a way to analyze data within specific time windows.
Okay.
So instead of just looking at an overall count, you might want to know, like, how many events occurred within, say, each 10-second interval.
Right.
Something like that.
And the blog post mentioned two main types of windows.
Yeah.
Tumbling windows and sliding windows. It seems like tumbling windows are kind of like those fixed buckets, right?
Exactly.
Like those 10-second intervals, one after the other.
And then sliding windows are a bit more dynamic. They're like overlapping buckets. So you might have, say, a 10-second window that slides forward every 5 seconds.
Interesting.
It's like a moving spotlight that focuses on these different chunks of the stream.
That's a really good way to put it. So I'm starting to see how you could use this to like track trends, like, figure out if there's a sudden spike in mentions of a particular hashtag on Twitter, for example.
Absolutely. That's just one example. Windowed aggregations are incredibly useful for making sense of data that's constantly changing. You can identify patterns, track anomalies, really understand the dynamics of your data over time. But to really get the most out of these techniques,
Right.
it's important to understand how Spark handles the state of your data. And that brings us to this distinction between stateless and stateful processing.
Okay, I'll admit this is where I started to feel a little bit lost.
Sure.
So stateless processing seems pretty straightforward.
Yeah.
It's like, evaluating each item on that conveyor belt independently,
Right.
without any memory of what came before.
A perfect example of stateless processing is filtering those error logs we talked about. Each log entry, we assess it on its own, right?
Right, right.
Does it contain the word error? Yes or no? And there's no need to remember what happened with the previous log entries.
Okay, that makes sense. But then you have stateful processing, which actually does require remembering those past events.
Exactly.
So the blog post used the example of like a running word count.
Yeah.
To keep track of that accurately, you actually need to remember the counts from all the previous batches of data.
Exactly, yeah. And that ability to remember past information becomes really crucial for a lot of these real-world applications.
Right.
Think about tracking user sessions on a website.
Sure.
You need to remember what actions each user has taken previously to really understand their current behavior.
Right. So it's like stateful processing is kind of like having a memory, which allows you to analyze data in a much more contextual way.
Yeah, exactly.
So it seems like that would be essential for anything that involves, like, tracking sequences of events or understanding user behavior over time.
You're absolutely right. And that's where things can get even more complex when we factor in the difference between event time and processing time.
Okay, event time versus processing time.
Yeah.
This seems like a really crucial distinction when you deal with real-time data.
Absolutely.
So the blog post kind of highlights that we need to differentiate between when something actually happens in the real world, event time, versus when the system gets around to processing it, which is the processing time.
Think of it like a package delivery system, right?
Okay.
The event time is when a package is actually picked up or delivered. But the processing time, well, that might be delayed because of traffic or weather or who knows what.
Right, all these unforeseen circumstances. So how does Spark actually handle these potential delays and make sure that data is processed in the correct order, even if it arrives out of sequence?
That's where this idea of watermarking comes in.
Okay.
Watermarking is a really clever technique.
Yeah.
That allows Spark to account for that late arriving data and ensure that events are processed in the right order based on their event time, not their processing time.
Got it. And the blog post had some code examples for both like event time and processing time windowing.
Right.
Which was helpful to see. So it's like Spark actually has these built-in mechanisms to kind of deal with the messiness of real-world data, where things don't always arrive in this perfect order.
Exactly. And to take it even a step further, Spark also allows for these local stateful computations.
Okay.
And this is where things get really powerful and flexible.
Okay, so the blog post uses the example of calculating a running sum and count for specific keys using this thing called map groups with state. And I have to admit, this part went a little over my head.
Well, think of it this way. Local stateful computation gives you very fine-grained control over how you're maintaining and updating state within your Spark application.
Okay.
It's like having a custom-built tool that can perform exactly the analysis you need, even for those really complex scenarios.
So if I wanted to keep track of, like, the top 10 trending products on my e-commerce site in real time, I could use these local stateful computations to do that.
Exactly. You could maintain a continuously updated count for each product and use map groups with state to define the logic for updating those counts and identifying the top 10.
Okay.
It gives you a lot of flexibility to really tailor the processing to your specific needs.
This is starting to sound really powerful, but before we dive deeper into these more, like, advanced features, maybe we should take a step back and just talk about the, like, really fundamental role of timestamps in all of this.
Yeah, timestamps are really essential in stream processing. They're kind of like the glue that holds everything together, providing that context to the data and allowing us to understand when things happened.
Yeah, it seems like timestamps are crucial for everything we've talked about so far, whether it's windowed aggregations,
Absolutely.
event correlation, really anything that involves analyzing data over time.
Imagine trying to analyze customer behavior on your website without knowing the order in which they took certain actions.
All right.
Timestamps provide that chronological framework
Yeah.
that we need to make sense of streaming data.
This has been a really illuminating deep dive so far. I feel like we've covered a lot of ground, from like the basic pipeline analogy
We have.
to the complexities of stateful operations and watermarking. But I feel like we're just scratching the surface of what stream processing with Apache Spark can do.
Yeah, absolutely.
So, like, what are some of the real-world applications of this technology?
Well, that's a great question, and one we should definitely explore further because the applications of stream processing are incredibly diverse and are really starting to revolutionize a wide range of industries. Yeah, it really is amazing to think about how far we've come, in the world of data analysis.
Right.
It wasn't that long ago that we were primarily focused on batch processing, just crunching these huge data sets to extract insights. But with stream processing, we're entering this whole new era of real-time understanding.
It's like we've gone from reading history books to watching live news feeds.
Exactly.
We're not just limited to understanding what happened in the past.
Right.
We can see the present unfold and even anticipate the future.
Exactly. And the implications of that are just huge.
Yeah.
The blog post touches on a few examples.
Yeah.
But I think it's worth exploring how stream processing is actually being used to kind of revolutionize different industries.
Okay.
This is where it gets really exciting.
I'm all ears. Let's start with something that everyone can relate to, like personalized recommendations.
Sure.
We've all seen those. You might also like suggestions on shopping websites or streaming platforms.
Right.
How does stream processing play into that?
Well, in the past, those recommendations were often based on your past purchases or browsing history.
Right.
It was all about looking at what you've done in the past to predict what you might want in the future.
Mm-hmm.
But with stream processing, those recommendations can be generated in real time, taking into account what you're doing right now.
So if I'm browsing for hiking boots on an e-commerce site,
yeah.
the website could use stream processing to instantly recommend things like hiking socks, trekking poles,
Right.
or even nearby trails.
Exactly. And it's not just about products.
Okay.
Think about music streaming services.
Sure.
They can use stream processing to suggest songs or artists based on what you're listening to at that very moment.
Wow.
Or even factor in things like your mood or the time of day.
It's like having a personal shopper or an entertainment concierge who knows you better than you know yourself.
Right.
Okay, that's pretty cool. But what about some more serious applications?
Sure.
The blog post mentioned fraud detection.
Yeah.
That seems like an area where real-time analysis would be critical.
Absolutely. Fraud detection is a prime example of where stream processing is making a huge impact.
Mm-hmm.
In the past, fraudulent transactions were often identified after the fact,
Right.
which meant businesses and individuals were already losing money.
Of course.
But now with stream processing, we can analyze transactions as they happen,
Okay.
looking for suspicious patterns and anomalies in real time.
So if my credit card company is using stream processing,
Yeah,
they could detect if my card is suddenly being used in a different country,
right.
or if there's an unusually high number of transactions happening in a short period of time.
Exactly. They could instantly flag those transactions for review or even block the card to prevent further fraudulent activity.
Wow.
And it's not just limited to financial transactions.
Okay.
Stream processing can be used to detect fraudulent activity in healthcare, insurance, government, really any industry where you need to identify and prevent suspicious behavior.
It's like having a digital detective constantly on the lookout for anything out of the ordinary.
Exactly.
That's incredible. Okay, I'm ready for my mind to be blown even further. What about self-driving cars?
Sure.
How does stream processing fit into that picture?
Self-driving cars are probably one of the most just mind-boggling applications of stream processing.
Yeah.
We're talking about vehicles that need to make split-second decisions based on a constant stream of data coming in from sensors, cameras, GPS, all sorts of other sources.
So you've got this car navigating a busy city street.
Yeah.
It has to process information about the position and speed of other cars, pedestrians walking across the street, traffic lights changing,
Right.
even things like weather conditions.
Yeah.
And it has to do all of this in real time to avoid accidents and make safe decisions.
And that's where stream processing is essential. It provides the framework for analyzing all that data on the fly, identifying potential hazards, and adjusting the car's course accordingly, all in the blink of an eye.
That's incredible. It's hard to believe that this technology is already being deployed on our roads today.
I know, it's amazing.
And I'm guessing it goes beyond self-driving cars. Are there other areas where this real-time analysis of movement and location data is being used?
Absolutely. Think about things like traffic management systems in smart cities optimizing delivery routes for logistics companies,
Okay.
even tracking the movement of people and goods across borders. Stream processing is revolutionizing how we understand and manage the flow of things in the physical world.
This is all really fascinating stuff, but before we go too far down the rabbit hole of these high-tech applications,
Yeah.
it's important to remember that stream processing isn't just for these cutting-edge industries.
You're absolutely right. Any business that generates data can benefit from real-time analysis.
Mm-hmm.
It's really about understanding what's happening in your business as it happens,
Okay.
rather than waiting for reports or dashboards to catch up.
So a retail chain could use stream processing to monitor inventory levels in real time,
Right.
track sales trends as they emerge, or
Exactly.
even personalize customer experiences based on what shoppers are doing in the store at that very moment.
Exactly. And a manufacturing company could use stream processing to monitor production lines, identify bottlenecks, and optimize efficiency in real time. Wow, the possibilities are truly endless. It's not just a technology, it's a new way of thinking about data and how you can use it to gain a competitive edge.
This deep dive has really opened my eyes to the power and potential of stream processing.
It is powerful.
It's amazing to think that a technology that was once the domain of data scientists and engineers is now becoming accessible to a much wider range of people and businesses.
That's what's so exciting about it. Tools like Apache Spark are making it easier than ever for people without those deep technical backgrounds
Right.
to harness the power of stream processing and gain those real-time insights from their data.
It's like democratizing data analysis,
Exactly.
empowering more people to make sense of the world in real time.
I love that.
I can't wait to see what innovations emerge as this technology becomes even more widespread.
I agree. It's an incredibly exciting time to be working with data. But before we get carried away with predictions about the future,
Sure.
maybe we should take a moment to recap what we've learned today and offer some final thoughts for our listeners.
That sounds like a great plan. We've covered a lot of ground in this deep dive.
Yeah.
And I want to make sure that everyone walks away with a clear understanding of the key takeaways
Right.
and the potential of this incredible technology. Okay, so we've really journeyed through this world of stream processing with Apache Spark. We talked about the basics of how data flows through that pipeline, right? The importance of immutability,
Yeah.
those powerful transformations and aggregations.
Absolutely.
We went deeper into things like windowed aggregations,
Right.
the difference between stateless and stateful processing, even how Spark handles those late arrivals with watermarking. And I think what's really remarkable is how this, one technology
Yeah.
can be applied to so many different fields.
Right. It's pretty incredible.
We've talked about personalized recommendations, fraud detection, even self-driving cars, managing traffic flow in smart cities.
It really is remarkable how these same underlying principles can be applied to such a diverse set of problems.
Yeah, and it's like this technology has so much potential to change the way we live and work.
Mm-hmm.
It seems like we're just at the beginning of this whole real-time revolution. As more and more data is generated in real time, the demand for tools like Spark is just going to keep increasing.
Absolutely. And as the technology itself keeps evolving, I think we can expect to see even more creative and groundbreaking applications emerge.
Right, what if you could use real-time data analysis to, personalize education, optimize healthcare delivery, even predict and prevent natural disasters?
You can. It's really amazing what's possible.
It's exciting to think about the positive impact this could have, but it also makes me wonder about the potential downsides.
Sure.
As we become more reliant on real-time data analysis, are we running the risk of making decisions too hastily without actually taking the time to, consider all the implications?
That's a great point. It's really crucial to remember that stream processing, like any technology, is just a tool. And like any tool, it can be used for good or for ill. So it's really up to us, as humans, to make sure that we're using these tools responsibly and ethically.
Yeah, I mean, we need to be mindful of things like data privacy, algorithmic bias, the potential for misuse.
Absolutely. Those are all crucial considerations.
So it seems like as we become more and more immersed in this world of real-time data,
Yeah.
it's important to maintain that sense of perspective and critical thinking. We need to ask ourselves, what are the potential consequences of basing decisions on real-time data? How do we ensure that this technology is actually being used to create a more informed, responsive, and equitable society?
Those are some really essential questions, and I encourage anyone who is interested in this world of stream processing to really, grapple with those ethical considerations, because ultimately the power of this technology, it doesn't just lie in the algorithms and the code.
Yeah.
It's the human choices that we make about how to use it.
This deep dive has been a real eye-opener for me. I feel like I've learned so much about not just like the technical aspects of stream processing with Apache Spark,
Right.
but also, the broader implications of this technology. And I think just the responsibility that comes with having these powerful tools.
It's been a really fascinating conversation.
It has.
And, to anyone listening who's feeling inspired to learn more, I would say dive in. There's so many resources available online.
Yeah.
The Apache Spark documentation is a great place to start, and there's tons of tutorials and blog posts out there.
And, you don't have to be a data scientist to understand and appreciate this. This technology is changing the world around us.
It really is.
It's something that everyone should be aware of.
So as you're going about your day, just start noticing how real-time data is shaping your experiences, from personalized recommendations that you see online
Right.
to traffic updates on your GPS. It's everywhere, and it's only going to become more prevalent in the coming years.
Yeah. Well, thank you so much for joining us for this deep dive into the world of stream processing with Apache Spark. Until next time, keep those beta streams flowing and keep those minds curious. 17i.